Then we have the problems of range. And the range really sort of alludes to the fact that we've been allocated 1900 megahertz. And 1900 megahertz was the frequency band that was allocated for UMTS, for TDD operation. A number of licenses were issued here in the UK, but the operators never really took advantage of those licenses. So that spectrum has been left really unused for the sort of past 25 years, I think. But the trouble with 1900 megahertz, it's twice the frequency compared to 925 megahertz. And if you double the frequency in a radio communication system, the actual signal level will fall by a factor of 4. And radio engineers often quote that reduction by a factor of 4 as a dB value, 6 dBs. The signal is going to reduce by 6 dBs. Therefore, the range is going to reduce. Now, currently with GSM-R working at 900 megahertz, the BTSs, the base stations, are located trackside, and the spacing between those BTSs is typically around about 8 kilometers. That's the so-called inter-site distance. Now, if we're going to double the frequency, what we're going to have to do is half the distance to actually keep the propagation loss the same. So that would actually give us a inter-site distance of 4 kilometers. Now, clearly, if we're going to replace GSM-R with FRMCS, it's going to take twice as many base stations. This is going to be really expensive to actually roll out. And it becomes even worse. The inter-site distance of 8 kilometers at 900 megahertz is applicable in rural locations. But when you get into urban locations, that inter-site distance can reduce to 4 kilometers. And of course, if it's 1900 megahertz, our 4 kilometers will reduce down to 2 kilometers. So yeah, you can appreciate that the costs are going to be very, very high. So are there any sort of techniques that may be improving the range of our 1900 megahertz cells? Well, multiple antenna systems, smart antennas, beamforming antennas are things which are commonly used by the commercial operators. Maybe we could start to deploy those in our railway environment. So in my diagram, I've got an antenna, and along this line, in this direction, I've got a mobile device. And normally what happens is when we transmit a signal from the antenna, if you're close to the antenna, you'll get a relatively large signal. But as you move further away from the antenna, the signal basically becomes smaller, it becomes somewhat attenuated. And by the time it reaches the distant mobile, it's going to be quite fairly attenuated. So a solution to that particular problem might exist if we had two antennas, okay, a multiple antenna technique. Now, what we're trying to do here is perform what is called beamforming. And for this to work effectively, the spacing between the antennas has got to be very precise. The antennas are described as being coherent, and the spacing needs to be fixed at half a wavelength. Both antennas will transmit exactly the same information. And of course, as you move away from those antennas, that signal will get progressively weaker and progressively weaker. But the mobile is now picking up two very weak signals. And what we can now do is combine those two signals together, and that gives us a nice big strong signal. So potentially, beamforming antennas or some derivative of those could potentially compensate for the increased propagation loss of using 1900 megahertz. There's also another factor. 3GPP have also announced a new power class mobile device for FRMCS. Currently, 5G mobile phones can transmit only 200 milliwatts of power, 0.2 watts. You compare that to a cab radio for GSM-R, it can transmit 8 watts of power. There's no comparison. 8 watts compared to 0.2 watts. That is also going to compound the problem. We've got a higher frequency, a higher propagation loss, and now, of course, we've got smaller amounts of power that we can transmit from the mobile. 200 milliwatts can be expressed logarithmically. It's often referred to as 23 dBs with respect to 1 milliwatt, a 23 dBm transmit power level. What 3GPP have identified is a new power class. This new power class radio can transmit 31 dBm. The difference between 31 dBm and 23 dBms is 8 dB. That more than compensates for the 6 dB additional loss by doubling the frequency. So maybe a combination of the high power mobile, multiple antenna systems, beamforming antennas might actually compensate for using at 1900 megahertz. And maybe we will have to reduce our intersite distance. I think Huawei did a good presentation at the UIC conference for FRMCS held in Paris last summer, and they sort of put some figures on the screen to suggest that potentially with smart antennas, with beamforming antennas, with the high power class mobile device, potentially we may be able to achieve the same intersite distance. But that remains to be seen.